Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this session of 8th Mathematics, Surface Area and Volume Part 3. Friends, in the previous video, we discussed around the curved surface area and total surface area of three-dimensional figure cylinder and a few problems based on it. In this video, we are going to discuss on the following important subtopics: cylinder, the volume of the cylinder, and problems from the practices 16.3. So friends, let us start with the today's session, that is volume of a cylinder. Volume of the cylinder. A cylinder is a three-dimensional solid shape that consists of two parallel bases linked by a curved surface. You can see in the adjoining figure. These bases are like a circular disc in shape. The line passing from the center or joining the centers of the two circular bases is called axis of the cylinder. You could see here, it is also height of the cylinder. The volume of cylinder is the capacity of the cylinder, which calculates the amount of material quantity it can hold. In geometry, there is a specific volume of a cylinder formula that is used to measure how much amount of any quantity, whether liquid or solid, can be immersed in it uniformly. A cylinder is a three-dimensional shape with two congruent and parallel identical bases. So friends, here you could see a cylinder whose radiuses are and height is h, and the formula for the volume that you are getting is volume of this cylinder is nothing but the area of the base into height. As the base is circular, so we can get the V is equal to pi r square, the area of the base, and height h is the height. So we can write the volume of the cylinder V is equal to pi r square h. This is a very important formula. Here we can get that r is the radius and h is the height of the cylinder, the distance between the two bases. So friends, this formula is very important. Let us start with the problems that are there in the textbook of 8th Mathematics, practice set 16.3. Number 1, find the volume of the cylinder if height h and radius of the base r are given below. Number 1, here r is 10.5 cm, h is 8 cm. So here it is given that r is 10.5 and h is 8 cm, and we have to find out the volume of the cylinder. Volume of the cylinder is equal to pi r square h. Pi is value is 22/7 into 10.5 into 10.5 into 8. R square 10.5 into 10.5. Here we will simplify this: 22 into 1.5 into 10.5 into 8, and the product of this is 2772 cc, that is cubic centimeter. So volume of the cylinder is 2772 cubic centimeter. So we will get right this one. Now r is equal to 2.5 centimeter, h is 7 centimeter. So here given things are r is 2.5 meter and h is 7 meter. So friends, we have to find out the volume of the cylinder. So volume of the cylinder is pi r square h. Now put the values: 22/7 into r value is 2.5 into 2.5 into h is 7. So after simplification you are getting 22 into 2.5 into 2.5, and the product of this is 137.5 cubic meter. So verbally or word we can write the volume of the cylinder is 137.5 cubic centimeter. So number 3, r is 4.2 centimeter and h is 5 centimeter. Given things, so volume of the cylinder formula pi r square h. Put the values: 22/7 and r is 4.2 given. So 4.2 into 4.2 and height is 5 into 5. So simplify this one: 22 into 0.6, 4.2 and 7 divisible. So 7 ones are 7, 0.6 is 4.2 into 4.2 into 5. So product of this 2777.2 cc. In word we can write the volume of this cylinder is 277.2 cubic centimeter. Fourth one, r is 5.6 centimeter and h is 5 centimeter. So friends, here this radius and height is given. The formula for finding the volume of a cylinder is pi r square h. We'll substitute the above values: r 5.6 and h 5. So next step will be 22/7 into 5.6 into 5.6 into 5 divided by 7. So 22 into 0.8 into 5.6 into 5. So that leads to 492.8 cc. So in word we can write the volume of the cylinder is 492.8 cubic centimeter. So friends, second problem, how much iron is needed to make a rod of length 90 centimeter and diameter 1.4 centimeter. So friends, here it is given that for a cylindrical rod, length of the rod is height h 90 centimeter and diameter is 1.4 centimeter. Here we will find the iron required, means we have to find out the volume of this rod. Naturally, here it is given that d is 1.4 centimeter, so r will be d by 2, that is 1.4 upon 2, that is 0.7 centimeter. And the formula for volume of a rod is equal to pi r square h, since rod is a cylindrical shape. So put the values 22 upon 7 into 0.7 into 0.7 into 90. So simplification, after you are getting 22 into 0.1, 7 and 0.7. Division is possible. So 22 into 0.1 into 0.7 into 90, and the product of this is 138.60 cc. So friends, you'll get that 138.60 cc of iron is required to make that rod. So we'll start with the next problem. Problem number 3. How much water will a tank hold if the interior diameter of the tank is 1.6 meter and its depth is 0.7 meter? Friends, from this problem we come to know that interior diameter of the tank is 1.6 meter and depth, that is height, is 0.7 meter. We have to find out the capacity of the tank, means you have to find out the volume, as this tank is here cylindrical shape. Interior diameter of the tank is 1.6 meter, so interior radius will be d by 2, 1.6 by 2, that leads to 0.8 meter, but we know that 1 meter is 100 centimeter. So 0.8 into 100, that is leading that radius is 80 centimeter. And the height h is 0.7 meter, means 0.7 into 100, that is 70 centimeter. Now capacity of the tank is nothing but the volume of the tank, which is cylindrical in shape. And the formula for it, pi r square h. Now we'll substitute the value. Pi 22 upon 7, r is 80, 80 into 80 into height is 70. So 22 upon 7 into 80 into 80 into 70. After simplification, we are getting 22 into 80 into 80 into 10. So that leads to 1408000 cc. But we have to convert it in terms of liters. So we have to divide it by 1000, since 1 liter is 1000 cc. So 1408000 upon 1000, that leads to 1408 liter. So in words we can write the tank can hold 1408 liter of water. Problem number 4. Find the volume of the cylinder if the circumference of the base of the cylinder is 132 centimeter and height is 25 centimeter. Here friends, it is given that circumference of the base of the cylinder is 132 centimeter and height is 25 centimeter. Volume of the cylinder we have to find out. Circumference of the base of the cylinder is formula 2 pi r. So we'll put the values, therefore 132, which is circumference, is equal to 2 into 22 upon 7 into r. So 2 into 22 upon 7, that is brought to the left hand side. So the next step will become 132 into 7 divided by 2 into 22 is equal to r. Therefore 3 into 7 is equal to r. You will get r as a 21 centimeter. As we once came to know the value of r, we can use the formula for finding the volume of the cylinder, which is pi r square h. So put the values here. 22 upon 7 into 21 into 21 into 25. Simplify this. You will get 22 into 3 into 21 into 25. That leads to 34,650 cubic centimeter. So in word you can write the volume of the cylinder is 34,650 cc cubic centimeter. So friends, what we have discussed today in this session is the following subtopics, that is cylinder, then formula for volume of the cylinder, and problems that are based on this aforementioned formula, that is the volume of a cylinder, which is pi r square h. So friends, we will try these problems. Find the volume of a cylindrical water tank whose base radius is 25 inches and whose height is 120 inches. Here the value of pi given as 3.14. The volume of the cylinder is 440 centimeter cube and the height is 35 centimeter. Find the radius of the cylinder of a base. So a pipe is 21 centimeter long. The inside and outside radiuses are 6 centimeter and 4 centimeter respectively. What is the volume of the water required to fill the pipe completely? Last one, calculate the volume of the cylinder where the area of the base is 30 centimeter square and the height is 6 centimeter. So these are the easy problems, and all those problems are based on the volume of a cylinder. Try this. Friends, what is the summary formulas that we have been used for this topic, that is surface area and the volume of a cube and cuboid cylinder? So it can be summarized in this table. Cuboid, it is having length LBH, then vertical surface area or curved surface area. It has not curved surface area is only for cylinder. So the vertical surface area, 4 vertical faces are there, and that area is 2h into bracket L plus B. Total surface area is 2 into bracket LB plus BH plus HL, and that volume is L into B into H. For the cube, if A is the side, then area of 4 vertical surfaces will be 4A square. Total surface area is 6A square and volume is A cube. For the right circular cylinder, if R is the radius, H is the height, then curved surface area, it has a curved surface area, that is 2 pi r H, and total surface area is 2 pi r into bracket R plus H, and the volume is pi r square H. So this table is important as far as this topic is concerned. Go through this again and again. So friends, Euler's formula. Leonard Euler discovered an interesting formula regarding the faces, vertices, edges, and the solid figures. Count and write the faces, vertices, and the edges of the following figure. You will get here the different figures they have given, their shapes, how many faces are there, how many vertices are there, edges are there. Here some 6 figures are given. First is cube, second is cuboid, then triangular prism is there, triangular pyramid is there, pentagonal pyramid is there, and hexagonal prism is there. Friends, here we will get that black color numbers indicates the given values. Red we have to find out, it has been already given to you. So we will get one equation from this all. If you take the case of this cube, 6 are the faces, 8 are the vertices, and edges will become 14. These are the edges, it is 12. So we'll get that addition of these two, 6 plus 8 is 14 and edges is 12, means addition of face and volume is more than 2 by edges. This edge is 12, 12 plus 2, that gives you 8 plus 16. For cuboid, 6 faces are there, vertices are 8, and edges is 12. So we'll get again the same thing, 8 plus 6 is 14. So 12 plus 2 is 14, means face plus phi, that gives you edges plus 2. For triangular prism, 5 are the faces, vertices 6, and 9 is the edges. Again 6 plus 5 is 11, 9 plus 2 is 11. 4 are the faces, 4 are the vertices, and 6 are the edges. You come to know from these 3 and these 3, 6 edges, vertices 4, 1, 2, 3, and this middle one 4, faces 1, 2, 3, and below one 4. So 4 plus 4, 8, 6 plus 2 is 8. For this pentagonal, you will get 6 faces, 6 vertices, and edges will be 10. Hexagonal prism, for this face is 8, vertices are 12, and edges are 18. So 12 plus 8, that leads to 20, 18 plus 2 is 20. So from this table we will get a formula like this. From this table, F plus V, faces plus vertices, is always equal to edges plus 2. This is nothing but a Euler's formula. So for any polynomial, 3D polynomials, you can verify this. Friends, you should not forget the famous words by this Paul S. Holmes, a Hungarian-American mathematician. He said that the only way to learn mathematics is to do mathematics. So practice more and more mathematics and create and develop the interest in mathematics. With these words, I would like to say thank you